Hello, Mr. Benjamin here, and today we'll be talking about percentage composition of elements in a compound. So if you can see over here, when a compound contains more than one element, right, the composition of the mass of the element can be calculated by using the mass of the element, right, divided by the mass of the compound. So how do we find out the mass of the element and the mass of the compound? What we're looking at is actually the molar mass, or the MR. So let's take a look at the first example over here. Okay, so the first one over here, we have the mass of oxygen in carbon dioxide. So we know that in carbon dioxide, I have one C and two O's. So firstly, we calculate the MR of carbon dioxide. So carbon is 12, oxygen is 16, there are two of them, so that's 16. So let's put that in the calculator, and that would be 44. So what we understand here is that the whole mass of CO2, like this, is 44, right? 1 mole of CO2 is 44 grams. So out of this 44, there is actually one carbon, right? And there's two oxygen. The carbon is 12, the oxygen is 16 each. So what we are asking over here is what is the percentage mass of oxygen inside carbon dioxide? So what should we do? We should take the total mass, which is over here, 16 plus 16, and we divide it by the total, 44, and we find the percentage. So let's do that. So it's actually the two O's over the CO2, right, times 100%. Okay, so as usual, make sure your working is clear. So 2 times 16 over the 44 times 100%, and you punch that into your calculators, all right, and you get 72.7%. Okay, so that's how you calculate percentage by mass of an element. Okay, let's look at another example. We want to find out the percentage of oxygen in calcium nitrate. So now the formula looks slightly more complicated, but we can break this formula down. So this means that there's one Ca, there is actually two Ns, right? Because the 2 and then there's a 1 here, so there's two Ns, and there's a total of 6 oxygens. So there's a total of 6 oxygens. So the MR of calcium nitrate is equals to 1 Ca, right, plus 2 Ns plus 6 oxygens. So we must be able to read the formula well. Okay, so calcium, I believe if you check a periodic table, that should be a 40. Nitrogen is a 14, there's 2 of them. Oxygen, 16, there's 6 of them. And therefore, that will give you a total of 164. Okay, so we want to find the percentage mass of oxygen inside calcium nitrate. So we want to see oxygen, which is the 6 O's, over calcium nitrate. Okay, and then times 100%. So the 6 O's is 6 times 16 over the MR of calcium nitrate, which we calculated, is 164 times 100%. Okay, and then if you do the math and you calculate that, what you get 58.5%. So that means 58.5% of the mass of calcium nitrate is actually oxygen. Okay, let's do one more example. Right, so we got a percentage of iron in iron 3 oxide. So iron 3 oxide is Fe2O3. So that means Fe2O3 means that there's 2 Fe and 3 O's. Okay, so that means 2 times, check periodic table, Fe is 56 and O's is 16. So we will get 160. So what does this mean is that Fe2O3, right, is total of 160. 1 Fe, 2 Fe's, and then we got 3 O's, right? And we know each Fe is about 56, 56, and then it's 16, 16, 16, so it's 160. So we want to find out the percentage mass of iron in iron 3 oxide. So percentage mass of iron will be the 2 Fe's, right? This 2 here, 56, 56, divided by the entire thing, Fe2O3, and that would be 2 times 56 divided by 160, right? And I believe that is 70.0%. Okay, so that's how we calculate percentage mass, simply put, right? Now let's look at another formula. So this is a formula that is a formula of a crystals. So we'll see that there's this dot here. This dot is called the water of crystallization. Now, this dot, right, it doesn't mean anything much. It just means that when I have 1 copper sulfate, I have 5 water surrounding it. right? So I just repeat, 1 copper sulfate, then 5 water surrounding. So if you want to look at a picture, right, it's like that. So if I have a copper sulfate, I'll have 5 water surrounding it. 1, 2, 3, 4, 5. Okay, you have 5 water surrounding it. So we need to calculate the percentage of copper present in the whole thing. So let's see. So we need to find the MR of copper sulfate 5H2O. Okay, the whole thing. So this is equals to 1 copper plus 1 sulfur plus 4 oxygen in the copper sulfate plus 5 water molecules. So copper, if you check your periodic table, is 64. Sulfur is 32. Oxygen is 16. And then water, 2 hydrogen and 1 oxygen, that will be a total of 18. Okay, you sum that all up together, you get 250. So that's the whole mass of copper sulfate, 5 water of the crystals. Now I want copper, so it's 1 copper over the whole copper sulfate, 5H2O, equals to 64 over 250 times 100%, and that would give me 25.6%. Okay, now if I want to calculate the percentage of water present, so now instead I need to put the 5H2O and find out in my copper sulfate 5H2O how much that would be. Okay, so 5 times 18, because that's 5 water, divide by the 250 times 100%, and that should give me, right, 36.0%. Okay, so that's how you calculate percentage composition of a particular element in a compound. Always do remember to put in the number of element or the number of water or inside here. So you can see here the 5, remember to put that in. When you're calculating the iron here, the 2, remember to put that in, right? That's usually the common mistake. Okay, so I hope that has been helpful. All the best.